In the previous video, you learned that ML is a way to use standard algorithms or models to analyze data. This analyzed data can be then used to derive predictive insights and make repeated decisions. The accuracy of those predictions, however, depend on large volumes of data that are free of bugs. Let me use a software analogy to explain what I mean by bugs. In traditional software development, a bug is a mistake in the code that causes unexpected or undesired behavior. In ML, even though there can be bugs in the implementation of an algorithm, bugs in data are far more common. Consider this example. A few years ago, some Googlers wanted to use ML to help diagnose diabetic retinopathy, which is the fastest growing cause of blindness, potentially affecting more than 415 million diabetic patients worldwide. Working closely with doctors in the US and India, these Googlers created an ML model that would diagnose diabetic retinopathy almost as well as ophthalmologists can. They trained an ML model using labeled images of the backs of eyes, each label being the diagnosis. Because humans were involved in the labeling of the images, the labeling system is not completely objective. The data may have included incorrect labels or even human bias, which is then propagated into the ML model itself. So how would you ensure that you have optimal data quality when training an ML model? The best data has three qualities. 1, it has coverage. 2, it's clean or consistent. And 3, it's complete. I'll explain each one. Data coverage refers to the scope of a problem domain and all possible scenarios it can account for. In other words, all possible input and output data. Let's imagine an auto manufacturing use case where the goal is to use ML to automatically identify defects in car parts. Let's assume also that the car parts are divided into red and blue. If red and blue make up all the possible scenarios, but you only train your model with red parts, the model might not be able to detect defects in blue car parts when it's presented with new data. So more data and broader coverage produce a more accurate ML model. The second quality of good data is its cleanliness. This is sometimes called data consistency. Data is considered dirty or inconsistent if it includes or excludes anything that might prevent an ML model from making accurate predictions. This is a lot like the errors or bugs we talked about earlier. The simplest form of inconsistency in data is data format. Suppose, for instance, you want to analyze data from multiple documents, and one of the data points on each document is a timestamp. The timestamps from all sources have to be of the same format. Otherwise, the data is considered dirty. Let's return to our manufacturing scenario. Where do you think inconsistencies could occur? Well, if you're using photos to look for defects in car parts, you need to be careful with which images you choose to train the model. For example, if the images have shadows in them, the model won't know whether shadows are part of an object or not. If you want to make predictions from images that are supposed to have shadows, that's okay. Otherwise, your data is dirty. I mentioned incorrect labels earlier, which is another form of dirty data. In this scenario, you might have parts that were labeled as fractured, but in reality they were discarded because they were the wrong size. There are lots of examples of human error that causes dirty data as well. Imagine the sales and retail industry, for example. If someone enters incorrect purchase data in a data storage system, this creates dirty data. If there's an error in an automated service, or if a transaction is recorded incorrectly every time the register runs out of paper, this also produces dirty data. The more incorrect or dirty data you have, the more correct and clean data you'll need to provide a counterbalance so the ML model learns the correct outcome. Another quality of good data is completeness. This refers to the availability of sufficient data about the world to replace human knowledge. Think of this as the various data categories or themes that help complete a user's profile, such as address, gender, or height. Incomplete data can limit the performance of an ML model. We say there's incomplete data when there's a lack of better data, there are mistaken expectations about how ML works and what it's capable of, or program design and implementation are poorly executed. Let's go back to our manufacturing example. Imagine that one of the major sources of defects is overheating, but you're not collecting temperature data. That's an example of incomplete data. Even if you start collecting temperature data now, you may not have the historical data that maps to past examples of good and fractured parts. Another form of incomplete data is the number of cases for all possible scenarios the data is intended to cover. In the same manufacturing example, your goal is to match the labels, good condition and fractured, with every part. If axle is one item you're evaluating for defects, you'll need examples of axles in good condition and fractured. If you don't have that data, your data is incomplete. Remember, data is the tunnel through which your model views the world. Anything the model can't see, it assumed doesn't exist. For example, if a model was given an image that only showed what's on the left, it might think the road was open and traffic free. In reality, if I show you the full image, the road is just closed. The good news is that most of these problems can be solved simply by getting more data. But you have to be purposeful in collecting that data. Do you need to improve coverage, improve cleanliness or consistency, or improve completeness? Remember, data is central to ML. If you're planning to use it, you'll need to account for as many possibilities when preparing your data before training an ML model. Now you might be wondering what kinds of skills or expertise you need to begin using machine learning in your organization. Before you go too far down that path, I want to reassure you that ML has become more accessible than you think. In the next video, I'll explore some Google Cloud ML solutions that you can use, some even right away, to bring new value into your business.